All right, so to start off, we're going to be talking about using Jamf APIs to create a native app. And so just to get a read of the room and gauge the audience, how many people have written code against the API before? Okay, using Bash or Python, some scripting language. How many people have written Swift before? Okay, a few of you. Great, awesome. Excellent. So just to be really clear, one thing that's a little intimidating for us is that this was billed as an expert session because it involves coding and whatnot. But we are novice programmers, and so in the session we're going to talk about getting started using the Jamf API and getting started writing a native app. And so to introduce myself, I'm Weldon Dodd. I'm the owner of Rewind Tech in Denver, Colorado. We're an Apple training provider, and we do some work with Jamf and other companies, but we're a managed service provider as well, and we provide Jamf and use Jamf for both education and small business.
And I'm Randy Sakes. I'm the network manager for Glencoe School District 35. We're a suburban school district outside of Chicago. We have about 925 iPads that we're using with our students, kindergarten through 8th grade, so kind of telling the story of kind of what I developed and weaving that in here along with what Weldon's done to kind of share our pieces and hopefully motivate a lot of you to find an idea and take it and build some code and make some awesome apps.
Okay.
Thank you.
Yes. All right, so the agenda for this session, we want to start with why we did this, what was the need that we identified, why did we choose to write a native app, and then we'll walk through a bit of the code. You know, what's the logic behind getting a response from the JSS API, how do we use that, and then we'll show a little demo of how this works. So for a business case, for us, what the problem that we wanted to solve is we wanted to be able to scope apps, VPP apps specifically, to a class in the sense of an Apple School Manager class, right? And that's not possible in the Jamf application. If you go to the native UI, class is not a scopable criteria, right? And it's not a criteria for a smart group, and so you can't do it directly. But using the API, we're able to grab a list of all the devices that belong to a certain class, and then from there we can create a static group and assign an app or scope an app to that group. So it's a really simple problem, something that we couldn't do in the native web interface, but that we could do in we could do using the API. And so we initially had a solution that worked with Python and at the command line. It worked great, but we wanted to be able to offer that ability to select a class, select an app, and then scope it through the API to more people and make it more accessible. And so creating a native app was a way for us to do that. It solved a few problems with usability and typing in the wrong thing at the command line, right? We fixed some of those problems with a native app.
Yeah. And then kind of, from my perspective, the pieces that I was looking at with this app is it really all started around the point of troubleshooting student iPads. So is anyone here in a school? So there's some hands in a school, which is awesome, so thank you for being here, other educators. Troubleshooting a device, we use configuration profiles because we don't want students to necessarily work on and change settings that they actually need. The problem is, for example, if a student changes their email password and they don't have the ability to update their account on their device, they can't actually update that password to get their email, to get assignments, and so on and so forth. And what we found is it's a very clicky workflow. If anyone had to remove a configuration profile from just one device because you don't want it to impact everybody, it's not hard, but it's this fact of configuration profile, get it, edit, click on scope, click on exclusions, add device. It's very clicky. And because of that, we had a really limited set of support individuals that were able to access Jamf Pro because we don't necessarily want everybody in there. We know we could work with user roles and whatnot, but we kind of wanted to shift that a little bit. And making that easier, kind of as Weldon had mentioned with his piece, making it more accessible, making it easier. A lot of people are familiar with their phone and they know how to tap buttons and they know how to use text fields. So building on those kind of native pieces through iOS, we're able to kind of build out an app that was easy to get used. And then kind of finally, along with that, by doing that, we were able to have increased access to frequent tasks. So things that we often do for us was restarting devices, updating inventory once in a while. Another important one that we ran into was removing and putting devices into loss mode. So as you can tell, I'm not a graphic designer based upon what this user interface looks like. But that was the end result of putting all this together. It's available on the App Store. But again, that way of taking a tool that was normally very techy and making it accessible to more people so they could actually use it within their deployments and their workflow and their environments.
All right, so just to address getting started, we'll go through a few different steps that both Randy and I went through for us to get started. So initially, you need to get used to the APIs and learn the APIs. And there's two different APIs at this point, Classic API and the new Jamf Pro API. And what you'll find as you look through this is that some endpoints are available on the Classic API, and they're not yet implemented on the new API. So for us, for example, classes, getting a list of classes from the JSS, that's available in the Classic API. You can look at some of this directly in Safari. I'll show that, and there's good API documentation as well. And initially, for us to work out the logic of, how do we get the list of classes, how do we get details about each class and get the list of devices from each class, we worked all this out at the command line at first. So we started with, Bash and Python and built out all the logic. So we could see how it works, make sure we're getting the right objects back, that we could understand the data that we're receiving, and what we needed to do to manipulate it. So I would recommend that to everybody. It's a great way to get started. But then what we needed to do was implement that in Swift. And so there's a bit of translation to take the code, the working code that we had in Python, and essentially accomplish the same features, same functions in Swift. And so one great way to do that is in Swift Playgrounds. And so if we could switch to the demo computer real quick. Here's an example of a Swift Playground. And it's hard to walk through code in a presentation, but I'll just do it quickly to show what's happening in this. So at the top, we're importing the Cocoa frameworks, and Alamo Fire is a framework that's used for replacing the NSURL session to get the JSON back. And then we're defining a playground. And then there's a few steps that we're doing here. So we're building the path. What's the JSS endpoint that we want to hit? Here it's classes. We're putting together the credentials, and we're telling the API endpoint that we want JSON back. So then we, right here, right? And then on this line, we're building the full URL with the base path and the API endpoint. And then we're telling Alamo Fire to go get the JSON. So all this here is resulting in printing this JSON string. So we can see here we've got a list of classes in JSON. And so what's great about this is I can make edits and see what happens in real time. So for example, if I wanted to find a specific class, I could say, let's find class 353. Oh, I got nil back. Anybody see my mistake? Well, this is the part I edited. So I just got the endpoint wrong. It's actually classes/ID/ the ID number. So if I go ahead and do that, sure enough, down here at the bottom, now I've got the JSON for this class object. So I can see, for example, right here, here's the list of mobile devices that are assigned to that class. So this is a really great way to work out the logic, figure out what you're doing in Swift so that you can start to build the components and see how it's going to flow into your app. You can go ahead and switch back to the slides for me.
Now, Weldon showed a great piece that was all command line. And me not being necessarily a big coder, I was looking at a different way to do this. And this was a little app I found. It's called Paw. And rather than build out the code to kind of work with the playground pieces, I was able to do this in a nice little GUI that lets me put in, for example, that same API endpoint, and I'm going to pull back my device because I don't mind pulling that information up here. And the data kind of being presented in this case is shown on the side there, and it's showing the JSON formatted data. So it's nice because using the API in a variety of different tools, there's a whole lot of different ways that you can actually get started to find these pieces out. The part that I love the best about this app is it has a little tiny window that allows you to pick the actual library you want to use, and it'll generate the code for you. So that made getting started with this really nice and really easy because I didn't actually have to write that first initial line of code to make this request and pull the data back. It was also really nice because as you start looking through it, there's some string variables that you can start finding. This needs to be something that is dynamic in the app. I can't hard code this in and have other people use it. So it was a great way also to start identifying variables, what are the pieces that need to change, what can I shift from something I type in statically into something that another person can enter in through a text box or possibly down the road something through like a managed app config distribution piece. So everyone has opened Xcode before, right? Has everyone gotten through the second launch? Like after that first launch goes and then you have to install some tools. It's a great spot to start out with. It's where the app that I had built kind of started. And the biggest piece I can say with that, I know Weldon has a great story too with backing me on this one. First off is using version control, not just in Xcode, use that in everything. Start small. The first time I did this, it was a stupid little button on the screen that when I pressed it, ran the code all static, and it gave me feedback actually in the console. So there wasn't really any app design behind that at that point, and kind of very modularly building and moving forward from there. And that kind of goes perfectly into version control because as you're doing this, I made so many mistakes and I learned so much about the right format and how to do different coding pieces that when I forgot to do it, I lost 20 minutes worth of work to try to figure out what did I just mess up with this line of code that doesn't work.
Yeah, for me, I mean, it wasn't the 20 minutes of work that I lost. It was the hour that it took me to figure out where I had gone wrong when I could have just rolled back. So, I quickly learned as well to implement source control on my project so that I could hit points when I knew it was working, right, and make a commit. It's working here, and then if I went down a path where it stopped working, I could go back to it real quick. Git is hard to learn. It's a little, the command line tools are a little arcane, to be honest, but there's some GUI tools available, GitHub Desktop, Git Kraken. There's a few others. Tower is another good Mac app for maintaining your Git repo.
And another great story on version control I heard yesterday is Control-Z is not version control.
Yeah.
So please don't use that, even if you use the pasteboard services. Xcode really is that piece that's going to let you build your interfaces. It's going to help you lay out your apps. It's going to be incredibly frustrating because as you change devices and you place buttons in certain locations, you need to think about screen sizes because an iPhone 10 versus an iPhone 5 has a different screen size to you. So potentially when you're designing this, some user interface elements don't line up properly. Or the piece of what happens if I actually want to turn the device and use it in a landscape mode. There's pieces also to think about in there with accessibility to make sure that everybody has the ability to use the app. So when you're designing and working at this from the get-go, kind of keep in mind that devices are dynamic, they're going to change, and it's going to be tough to pick just one specific layout. Buttons move all over, text labels suddenly are on the top left of the screen, or a button now has disappeared that you need access to. So it's definitely a challenge at times.
Yeah, the first time I hit auto layout, I put a label on top of a table, right? And I figured, well, the label should stay with the table, right? And when I resized the window, the label was actually relative to the size of the containing window, not the table it was with. So as you resized it, the labels moved all over, right, while the table stayed where it was. So it took a little while to work that out. And honestly, in terms of moving our app from Python into Swift was pretty straightforward. Getting the UI to work because I was doing it for the first time, that probably took, I would say, it was 10 times the work. Right? So getting the logic to work, but learning something new always takes longer.
Yes.
So for us, we talked a little bit about why we did our projects, but for choosing to build a native app, we wanted the user experience to be better in using the tool. Using a command line tool can be a little intimidating for some people, but it also gave us a way to distribute the app. What we built in Python, we were using Python 3. That's not the native Python on most machines, so it required an additional install. It was great for me. It worked really well on my computer, but it was hard to move around. So it gave us a way to move the app. And then also, something else that was a great benefit was we were able to store the credentials for the JSS in the native keychain, where they're secure. We didn't have to worry about how to store or obscure the API credentials in a script, which is always kind of difficult. So we were excited about that benefit as well.
Yeah. It's also neat because once you store that, if you actually delete the app and then reinstall it, because those credentials were saved in the keychain on that device, they're going to pop back in. So it's kind of a neat way that you can leverage the security. Apple's really great on that, and rather than try to use a way that I think might work, I would much rather use Apple's route on that. I know they put a lot of thought and time towards data privacy and protection, and that's a great framework to keep using.
All right, so we're going to talk through the steps that we use to use the API in a native app. And there's a few different steps that we need to accomplish. So first, we need to build a connection. How are we going to talk to the JSS API endpoint, Jamf Pro server API endpoint? We'll need to get some data from the server. We'll need to do some work with that data. And then maybe we want to send some data back to update an object or to create something new. So for example, in our case, we needed to get a list of all the classes, right? Then once we identified the class that we wanted to scope an app to, we needed to get a list of all the mobile devices that are assigned to that class. The API returns the list of devices with their UDID. But in order to build a static mobile group, we need the ID, the JSS ID of the device. And so then we had to go and ask for the ID of each of those devices using the UDID we got earlier. Now we have an array of device IDs that we can use to create a static group. Now that static group exists, we can scope an app to that static group. So in that middle step of fetching data and processing data, we had to loop through a few times, right? Get some data, do some work to build an array, go get some more data, build a new array, and then finally we have the object that we want to send back to the Jamf Pro server to create something new. So that connection, here we're using Alamo Fire as a way to build the HTTP request. And first, I'll just introduce this before I get into the logic here. This may be a good point to introduce the idea of using some libraries in your app in order to speed up certain functions. So Alamo Fire is a great resource as it replaces NSURL session, which is maybe a little harder to work with. Alamo Fire presents a really nice, easy API to make your HTTP request. One thing that comes up, though, is that as you introduce these libraries and include them in your app, then that's something else that you need to check on and maintain and make sure it's kept up to date. Is it going to break in the future if the maintainer doesn't update it to work with the latest version of Swift or Xcode or whatnot? And so as an example, initially I'd looked at using another library to help process the JSON that I got back from the request. And in Swift 4.1, Apple added better JSON support. And so I decided to drop that extra library and just use the native JSON support that's in Swift 4.1. Because it made my app a little bit cleaner, it was one less thing that I had to include. I had to worry about dependencies and so on. But with Alamo Fire, Randy and I both use it, and we both kept it because it provides enough benefits. There's a big enough community around it that it felt worthwhile. So just something to consider as you're going through your project. It'll be really tempting to import a lot of libraries to make certain functions easier, make things work for you. You might get code examples from Stack Overflow right, that use a certain library, it's really tempting to then import it and use that. Just keep in mind some of the costs that go with that. It's something else you need to check on and maintain and make sure is up to date. But let's walk through here building the connection. So in Alamo Fire, we first need to build the URL. So we're using variables here, the base URL and the API endpoint that we're using, and then the XML that we're going to send. Well, that gets later. The parameter that we're going to check as part of that URL. We're using the get method to retrieve data from the Jamf Pro server. We specify the authentication, so we store the variables for the user account and password. Again, we can use the native keychain here and populate those variables from the keychain data. And then lastly, we're specifying that the response we're expecting back is going to be JSON so that we can handle that. Okay. At the very end here, we're checking to see if the response result is success, so that if it's not, we can stop and kind of exit gracefully instead of crashing the app. This is also, we'll see later on as we get into more error checking. This is a spot where you could add a lot more code to check for the actual status code. Is it 404, not found? Is there some other error, right? And present something back to the user.
Mm-hmm. So that was just the first piece of kind of going through just building that connection. And using the screenshot of the app that I have up here, there's that thought of, all right, well, how do we actually fetch this data? So in this case, the button that we have for this, I believe, is going to be lookup user. And this is where we actually start seeing the connections that we build out to Xcode. In this case, we're working, you'll see that function called is add IB action, so it's an interface builder action. And what's different about this is now we're starting to work on building code that is at the Cocoa level, that's the visual piece, versus I think what a lot of us here write through command line pieces that are scripts, that are lines and lines of code that look exactly like this. So what's interesting is then you have more nuances to work with, because instead of just thinking about error handling of is a variable present, you have to start looking at pieces that are related towards UI elements. So the first one up here is, has anyone played with using text boxes in Xcode and trying to get the status behind them? Okay, so there'll be probably a person or two that will understand this a little bit. The button that we're actually working with, or the text field that we're using with, is the one to the side of lookup user. It's called user to check. And within that, there's pieces that are optionable variables, because a text box may have text. So in some circumstances, you actually have to call this out and say this is an optional variable that may not be present. A text box may not have text. At the end of it, there's an exclamation point, and at the front, which is probably really confusing to look at if you haven't programmed within the Xcode interface at all. And that's the concept of force unwrapping a variable. And if you do force unwrap a variable, you need to be really, really sure that you have a way to error check that, because if you force unwrap a variable that's nil, so going back to Weldon's example earlier with the class that we had the typo on, the endpoint, that's going to be a very bad thing, because your app's going to crash because you force unwrap something that doesn't exist. So what's interesting with this is we're taking an optional text field that may have a value, we're saying is it empty or not, and then we're making sure that there's an entry in it. So when you work through the interfaces, you're going to get all sorts of Xcode hints that are going to ask you about this. You'll definitely be working through them a little bit. The next piece that's kind of in there is presenting some feedback to the user. So that way, someone knows we're looking data up. If you just tap a button, what is it like when sometimes have printed a document? If there's no interaction to tell them they've printed it, how many times do they print it? Probably more than once. Or if there's no indicator that something's actually going on, they keep refreshing a web page, which just makes it take even longer. So presenting user interface elements back to them is also a nice way to give some input into the status behind it. We work with kind of that same idea of button border colors. So I used warning. I was going to use yellow, but yellow doesn't really show up on a screen great, so it's this orange interface. If we tap the button and the user has input text, we change the border to kind of be orange. And the thought behind that is that's a pending operation. And I'll talk a little bit more on the color piece in a moment. And then lastly, we kind of work through looking up this data. That same way we built the connection earlier, we're doing that same piece again. So we're looking at information. This time we're pulling in the username. The past item in this case is used as a variable to the next function, so I can have one chunk of code rerun independent upon which of the 3 buttons gets pressed.
All right. So here, once we get the data back, right, then we need to get it ready to process. So in this example, Randy created a class for his application that once we retrieve all the data from the API endpoint, we can map it directly to a class so that we can use some of the native Swift features and Cocoa to work with that object. So here we're mapping a mobile device or in the general section, the device name, right, to an attribute of this class that we have, OS version, et cetera.
And really knowing your data is important because if you're trying to find where's the device name, you kind of have to know what array or what dictionary or how to find it. So that allows us to do it. I talked about error checking a little bit again. So when we looked at what we were passing here, previously we were passing in, I think it was username, was the actual string. So we're able to have this one function actually work again for all 3 buttons. If you can make code reusable, please try to do that. It will save you a whole lot of time, and it'll save you a whole lot of potential typos, which is also a very good thing. And that idea, again, of error handling is it's so important. In this case, we're going to do the request, and before we even process, we want to make sure, is it successful or not? But there's another check that I have running in here, because the idea of what we see with the API as a successful request is we made it, there wasn't an error. If I'm looking at devices, and let's say I put in my username, and I don't have a device assigned to me, that request still is successful. But the challenge here is I need to make sure that I'm actually getting mobile devices back, because if I don't have a device assigned, even though it's a successful API call, if I don't have data, I'm not going to have anything to work with. And this is a piece I look at and I say, this probably coding is a little bit lazy to say. And it's definitely something I'd work on changing later, is I've actually hard-coded in. I'm looking at the first item in the mobile device array and using 0. Don't be like me. Don't be a lazy coder. Something eventually I want to try to fix so that I'm not looking at a specific instance that's hard-coded, but kind of being more dynamic. And then lastly, again, this piece of iteration and having to work through multiple pieces. If I look for a user, I can get the device that's assigned. Now that I have the device, I actually have to now get the details about that device, and then we jump into yet another function. Aren't functions great? We have to process the data after it's fetched.
Okay. So here, grabbing the data again, we have this class defined so that we're going to take the data that we got back and map it to our class. The benefit of doing this, instead of just say, for example, parsing the JSON directly and pulling attributes out of the JSON, is that if the API were to change in the future, we would have to change all that logic to go and search for a different string or search for in a different place in the tree of the JSON that we're getting back. So by defining a class that we want to use, if something changes with the API in the future, right, we can modify the mapping instead of modifying all our logic that works on the data that we get back. So we've gotten all our data in here. We're going to check for the presence of these different values, the keys, right, and then map the values into our class. So for example, mobile device, we want to get the device name out of there.
Also, in that previous slide, there were some pieces of using if-lets. Those allow you to potentially have an error condition, but exit gracefully. Because if it's an if it fails, it actually causes the statement to be false instead of causing a crash. So it's kind of a neat way to work through that. That idea of working with user interfaces and trying to pick pieces that are familiar. Working on, in this case, the free space that's on a device. We have little indicators that are actually adjustable, so depending upon the needs of your organization on the space that's in use, you can present pieces like the free space status icon. If it's at a critical level, is red because typically that's a bad thing when that happens. If it's at a warning or kind of that idea of that pending state, we can have it in an orange piece. And then the last piece that's on there at the bottom is looking at actually taking all those variables that have been processed and then passing them back into the interface text fields. So we have full name label, serial number to check.text, so on and so forth, to actually pass them back into the application. Because getting the data is one thing, but again, we want our users to actually have something they can look at. So we have to take it from the code level and then pass it up into the UI level.
So here in this example, we want to send something back. We want to update an object or maybe create a new one. And we're using Alamo Fire again to build our connection. So in the highlighted line, right, we have the base URL plus the API endpoint that we want to connect to, as well as the XML that we're going to send back. So that's included in this string that we're building. The method here you'll see now is post. Okay, so that we can send new data to the Jamf Pro server. And then, again, a little bit of error checking just to see did we get a successful result. Mm-hmm. And again, this is where you could extend your code. So there's status codes that the Tomcat server will send back. So 201 is a successful status code in this example. You might see a 409 if you sent malformed XML, things like that. So you can add additional checks at this point to make sure that what you're sending works, and then if it doesn't, maybe present a more helpful message to the user about what went wrong, right? Because some of you, I'm sure, get tickets from end users. Anybody ever come to you and say, well, it just didn't work, right? And then you ask, well, what didn't work? And they say, I don't know, right? It didn't work. So if you can include some additional messages in your app that say, well, it wasn't found, the XML didn't look right, something like that, device wasn't found, that class doesn't exist, so on. It can help you when you get the ticket to try to help them out.
Because I think everyone's gotten here, you've probably worked on an app or something where it has undefined error. And you sit there like, why did the developer not try to help that out a little bit? Well, now that you're the developer of an app, you get to actually implement that. So you get to say, wow, if I was using this and this popped up and there was something that just said unexpected error, what would my reaction be? And then lastly, kind of that piece around the border colors a little bit. I'll go back. No worries. I'm going to pop up one. So I use those like a warning color. If the response is successful, we're going to put the border color, success color. Does anyone want to guess what color that might be? Green. All right, excellent. It's like all the lanyards out here, which is awesome. Actually, that's pretty good considering that the color codes fail. You want to guess? I heard red. So kind of that idea of picking colors, and as silly as it sounds, thinking of that user-centric design, picking pieces that are universal, that a color indicator can provide the status is really kind of helpful and meaningful because you don't then need to explain it. I know Weldon mentioned you can then use those error codes to actually give some more verbosity into the issue. Those are also excellent to put in place.
All right, we have a quick demo. So I'll let Randy walk you through this.
Sure. So this is, I'm going to use my device because I apparently lose it often. But like a quick example of what this can do, if you look at the user face elements, you'll see them kind of do their color changes. But for our students, we have this quite often. I've lost my device. Where is it? Using the Jamf interface, a couple of clicks to get there. But instead, if I write an app, have a couple of buttons, a lot of people can do this on their own. If there's a quick and easy way they can tap one button and have this all work, they can get that. It works pretty quick, so if I hit disable loss mode, usually in about 4 or 5 seconds, that device will kick out of the loss mode and it'll actually say that it's been located and continue. So that was a way we were trying to take a common task we were getting because this student, this person lost their device. Do you know where it is? No, I don't, but I can play a sound on it. And hold on, let me get my phone out. What's their name? Or I can't really scan their barcode if they've lost it. But if you use that for other inventory asset tags, or you have a list of all of those, you could just flip through the page, find their barcode, scan it, put the device into that loss mode, and again, it makes it more accessible so that IT isn't the only group that can do that. We could actually give this to our teachers if we wanted and have them make lots of musical noises in the hallways when students can't find their devices. That's just a quick little demo on how that piece works out.
Yeah, so between us, the app that we created in order to be able to scope apps to a class was a feature that wasn't available in Jamf. But using the API, we were able to create a simple tool that allowed us to do that. In Randy's example, he took some existing features like putting a device into lost mode, but presented it in a simpler, easier to use interface. Something that you consider you could hand out to a teacher and give them the ability to do this, or if you're in a work environment, someone who's the office manager, whatnot, has the ability to do a few simple tasks without trying to teach them how to log into the full Jamf web interface and navigate through all the different tabs and features to find what they're looking for. So hopefully this has given you some ideas on what you could do in your environment. It gives you a place to get started and think about projects or ideas that you could implement as a native app. Particularly if you already have some code that's working in Python or some other language that you want to build a better UI for. It's pretty easy to get started, and it took me some time to learn Interface Builder and how to wire up the code to the actual interface and the buttons. But it's something that can be done, and you'll spend a lot of time on Stack Overflow like I did. But it works.
And another piece to add with that, I think that's really important to think about is Apple has taken, I think it's the News app, and a handful of other apps that have been iOS only, and been able to port those over to the Mac side. So if you're thinking potentially of how do I write an app, what potential audience do I have, I don't know what that coding timeline would look like, but if we're starting to see Apple have a way to take iOS apps and bring them onto macOS, there's a great way that a tool like this you can leverage and develop for one platform might have portability to another in the future.
Well, we have a few minutes left, so if anyone has questions, there's 2 mics up here at the front, and we'd be happy to try to answer any questions as best we can.
Thank you, guys.
Hey, thank you all for attending. Uh-oh, is this going to be a coding question? Oh, boy.
Yeah.
Let me pull up Stack Overflow to find the answer.
Yeah.
Sorry, I missed what your app was called, and can I get it in the VPP store?
It is available in the VPP store, and the app is JAlly.
All right, you need to learn self-promote yourself better.
It's also in the Jamf Marketplace, so if you haven't looked through the Jamf and resources that are out there, it's
Thank you.
there as well. Yep.
Awesome. Well, if there's no other questions, thank you again for coming. It's great to see you all at JNUC. We really enjoy being with all of our fellow Mac admins. Enjoy the rest of the show, and safe travels home.